Functions Day 2. So a friendly reminder about domain. Domain is asking for all possible x values. And this year, I really want you to communicate that information in interval notation. And as a reminder, interval notation uses brackets and parentheses. So if you're seeing brackets, that means including the actual number, and round parentheses is not including. Finding the domain of an algebraic function, two things make this difficult for us, specifically fractions and radicals. So I'm going to go through some examples that include those today. Let's look at a rational function. This is a fraction because we have a variable in the denominator. Here's the problem. We can't divide by 0 because that makes the entire function undefined. So instead, what we're going to do is we're going to set the denominator equal to 0, and then we're going to solve. And what that does is it gives us the values that cannot be in the domain. So let's take a look at an example. We have a fraction that has variables, and the variables are in the numerator and denominator. But we want to focus on the denominator. We cannot have the denominator equal to 0. Because if it does, then that means that the entire function is undefined. And if it's undefined, then it's not part of the domain. So what we're going to do is we're going to set the denominator equal to 0, and we're going to solve for x. In order to solve for x, we have to factor. So when we factor, we're looking for numbers that multiply together to get 12, and those same two numbers have to add together to get 7. And then we're going to solve for x. So we take each parentheses and we set it equal to 0. We isolate the x, and then we have our two answers. Now remember what I said above. This will give us values that cannot be in the domain, because if they are in the domain, the function is undefined. So now let's write our domain, and let's write our domain in interval notation. So remember, our domain is everything except for these two numbers. So that means it goes from negative infinity, paired with negative infinity is always around parentheses because negative infinity is not a specific number. We're going to go from negative infinity all the way to negative 4. Now it doesn't equal negative 4, so we have another round parentheses. Once we leave negative 4, we go from negative 4 all the way to negative 3. And then when we leave negative 3, we go all the way to infinity. This is how we write our domain in interval notation. So what we've done is we've accounted for every single possible x value except for negative 4, because we were saying that we do not include negative 4, and except for negative 3, with those round parentheses, we do not include negative 3. The other issue is with our radical functions. This is what a radical function looks like, also known as the square root function. The domain of this function, so the x values, start at 0 And you can see that this is a closed-in circle and goes to positive infinity. Again, we have a round parentheses with infinity because infinity is not a specific number. So the numbers under a radical when simplified must be greater than or equal to 0, meaning they have to be 0 or a positive number. The reason why they can't be negative is because you can't take the square root of a negative number. Now, if this radical is in the numerator, the rule is we set the expression under the radical greater than or equal to 0, and we solve for x. And if the radical is in the denominator, we set the expression under the radical greater than 0. Let me write that down for you. So let's do an example. Determine the domain of f of x is equal to 4 over the square root of x minus 3. So looking at the rule that I just wrote above, the radical is in the denominator. So it says set the expression under the radical greater than 0. Now you might be wondering, why not equal to? And the reason why it's not also equal to is because we can't have a 0 in the denominator. So the denominator cannot equal 0 because then the entire thing is undefined. Let's solve. Square both sides. And this is our domain. We want to complete this by writing it in interval notation. So our answer is all x values greater than 3. So that means that the smallest number is 3. It's a round parentheses because we're not including it, to infinity. The last question we're going to look at is a piecewise function. A piecewise function means that we take different graphs and we graph them all together on the same xy plane. We limit the domain, which is what you're seeing over here on the right hand side. So this graph, and we're not actually graphing them, we're just going to evaluate them. The first one is the equation for x, but that equation only exists for the domain between 0 and 15. The equation of 60, so y is equal to 60, only exists from 15 to 240. And the equation y equals negative 6x plus 1,500 only exists from 240 to 250 with the x values. So the first one says find r of 5. So that 5 is replacing the x value. So we want to find the domain where the x value of 5 falls. So we look at our domains, and 5 falls between 0 and 15. So what that means is that we're going to only look at this first equation. I take the equation of 4x, and then I plug in the 5. So r of 5 is equal to 20. Now something that's really important, you do not sub that x value of 5 into any of the other equations, only the one where 5 falls into that specific domain. Done. Now let's find r of 15. So the x value is 15. So we look at the equations. Where does 15 fall? So you'll see 15 in two different spots. One of the equations includes 15 and one doesn't. The one that includes 15 is the top one. So we're going to use that top equation again. Again, the really important thing is we only plug that x value of 15 into one equation and not the others.